All right, so this is just going over 8-4. Check your homework along with it and see if you have any questions. If so, email me if you are at home. All right, so again, just as a real quick, rate of change is the same as slope. Slope is rise over run. It tells us they're linear, so we know the slope, no matter where you pick along the line, it's going to be the exact same. So one person might have picked, I'll do it in blue. One person might have picked these two, and somebody else could have come along and picked these two. And it doesn't matter because when you reduce it, it's all going to end up being the exact same number because the slope is constant across the entire line. All right. So if I pick those bottom two here, I'm going to do rise over run. So I'm going to do my rise, which is my change in Y. So I go from 0 to 2. So I rise 2 over my run. And I run from here, which is 0, to here, which in this case is a 1. Now you have to really watch because going up the side, my Y's jumped by 2 every time. So one block, right? Going up one block represents a move of 2, whereas left to right, one block here only represented a change of 1. So you really have to watch how your X and your Y axis are numbered because it's going to change your answer, right? If I just looked at this and said, right here, I went up one block, and so I put a 1 there, I would have the wrong slope because it totally is determined by how your y-axis is numbered. It could be 0, 5, 10, 15, 20. It could be 100, 200, 300, 400. It's just how each individual table is labeled. Okay, so you got to watch that. You can clean this up a little bit by just writing 2. I will never count this wrong. If you leave it 2 over 1, that's fine. I actually teach in my algebra classes. I actually teach them to leave it 2 over 1 because when you go to graph these, you are going to need the 1. You have to know the rise and the run. So I actually encourage my students to leave it as a fraction over 1 rather than doing this. Okay, but either one is technically a correct answer. All right. All right, for number 2, it's not a graph. Instead, it's a table, but you still look at your change in X, which is I go up 1 every time. And it matters whether you go up or down, so make sure you label it plus and minus. But to go from 1 to 2, that's a plus 1. And because it's linear, it should be consistent all the way, and it is. Okay, it's plus 1, plus 1, plus 1, plus 1. Now you look at your change in Y's over here. Well, you go from 2100 up to, so it's a plus, 2350 or 23,500, and that is the difference of 2,500. If you calculate it, it's also the same difference here, and it's also the same difference here. Because they tell us it's linear, we really only need to do it once, okay? Because we know, because it's linear, and that this right here is what's important. Because they tell us it's linear, we already know each change is going to be the same along the way, all right? So I would write this slope as my change in Y, which is my 2,500, over my change in X, which was 1. And again, you can write it like that, or you can clean it up and write it like that. And I'm fine with either one. Okay. This one, again, you can pick 2 points along here. It doesn't matter what 2 you pick. I'll pick this point and this point. Okay. And now, remember I said in the video that rise can actually be fall, right? Run's always run, but rise can actually be fall. And if I make my triangle here and then here, I actually have to fall, right? From this point to this point, I have to fall. And how much do I fall? Well, again, you've got to look at the way your blocks are numbered. If this is 80, then this is 70, right? So I fell 10 spots. So I fell 10 and then I ran. Well, again, you got to look at what one block means in your run. I run right here, 1 block. Well, 1 block represents, if this is 5, then half of this would be 2.5. So I run 2.5. Okay. And if you want, you can try to reduce this, right? Put in your calculator 10 divided by 2.5 and you get 4. And again, if you want to put 4 over 1 or if you want to put 4, I'm fine with either one of those. okay, as long as you try to reduce it. Are we good there? All right, I'm not going to worry about doing number 5. It's the exact same thing. You look at your change in Y, you look at your, or I'm sorry, your change in X, you look at your change in Y, and you always make sure and put your change in Y on top. Okay, Y's on top, rise over run. Same thing here. I said in the video, you always want to make sure and pick good points. And what do I mean by good points? This one's right on a cross. This one is a terrible point, right? Because it's not right where two of your graph lines intersect. This is a bad point. This, however, is a good point. So I would not use these 2 points because they are not right on a crisscross. I would use the point at the bottom and then the point at 7.52. Okay. And again, now you're looking for your rise. Nope. Looking for your rise. Always draw the triangle is going to help you so much with slope over your run. Okay, and then you want to look at how much did you rise? You rose from 0 up to 7.5. So I went plus 7.5 on my rise. And then on my run, I went from 0 and I ran over to 2. So I had a plus 2 on my run, or a plus 2 on my run, right? And so when you're writing your answer, it's 7.5 over 2. Right? And that can't be reduced, so you would just leave it 7.5 over 2. Sound good? All right, flip over to the other side. I'm not going to spend a whole lot of time on this side except for the bottom because this is why I put these 2 together. These 4 problems are exactly what you just did. Okay, it tells you right off the bat, makes it easy because it tells you that they're linear. So you know no matter what 2 points, you're going to get the exact same slope along the line no matter what. Okay, and you're still going to do it the same. You're still going to do your change in X, which in this case is plus 1, over your change in Y, which is plus 4. Because it's linear, you don't have to do it all the way down. If you want to glance, you can see that it goes up 4 every time, right? But your slope would be 4 over 1 or 4. Here, pick 2 points that are good points. You got several good points here to pick. Your rise over your run. Your rise here, you went from 0 up to 6, right? You got to look at how you're numbered, but 1 block here represented 6. So I went up 6. I ran from 6 to 9, and that is a run of 3. And so my slope is 6 over 3, which reduces to 2. Okay. What if I had picked, and I just want to show you this, okay? What if I had picked this point and this point? This point and this point. I just want to show you, okay? My rise would be here to here, and my run would be from here to here. Make a triangle with your points. My rise here represented is from 6 to 18, which is a rise of plus 12. My run, which is right here, is from 9 over to 15, which is a plus 6. And when I write that as a fraction, I get 12 over 6, which reduces to 2. So you get the exact same answer. No matter what 2 points you pick, it's always going to reduce down to 2. All right. All right. I'm not going to do these 2 because it's a lot of the same, but I do want to talk about the bottom here because this one tended to trip up a few people. So it asked whether a proportional linear relationship exists. We already know they're all linear. It told us that at the beginning of the assignment. So putting linear and nonlinear, they're all linear. We already know that. Proportional is different than linear. And this is what I talked about in the very end of the video. There's only one way to determine whether it's proportional. And that is you have to take each one of the points. So this right here is a point. It's an XY coordinate, right? This is a point. This is a point, and this is a point. I'm going to take each one of these points and I'm going to write it as a fraction with the Y on top. So the first point right here is the point 1, 4, and I'm going to write it with the Y on top. So 4 over 1. Then my next point in the group is this point right here. I'm going to write it 8 over 2 because I want my Y on top. My next point in the group is this point right here, and I'm going to write it with the Y on top. So 12 over 3. And then my last point is the point 416, and I'm going to write it with a Y on top. Okay, now I reduce these all, and I get 4. Because they all reduce to a matching proportion, Colton and Damien, either stand up or sit up. Damien. Damien. Sit up, stand up, do whatever you got to do to wake up. Okay, no sleeping in my class. Or else I'm going to come to your house tonight at 10 o'clock and teach you math. That'll be weird, won't it? All right. So every single one of these reduced to a matching ratio, which means you answer yes. You can't just answer yes or no. Okay. It says explain your reasoning. What did I say in the video? What's your explanation? All of this work. If you don't show the work of why you said yes or no, then you didn't do the problem. Okay. All right, I'm going to skip number 2 and I'm going to go to number 3 because I want to do an example of when it is a graph. You don't do it any different except it tells you to skip this point right here because 0 over 0, it's not a good, you can't use that as a ratio. So I'm going to move up to the next point, which is right here. And I'm going to write the coordinates of this point with the Y on top. Well, the Y is a 1 and the X is a 20. So for number 3, it would be 1 over 20. Then I'm going to look at the next point, which is right here. And I'm going to write the coordinates of this point with the Y on top. Well, my Y is a 2 and my X is a 40. So 2 over 40. And then I'm going to do the same thing with the next point. The Y is a 3, the X is a 60. So 3 over 60. Hopefully you can see the pattern forming. And then you've got 4 over 80. And you could keep going. And you could do the last one here of 5 over 100. And when you reduce every one of these, right, that's already reduced, that reduces, and you can see that each one of them reduce. And because these match, then you would answer yes. But again, this right here, you have to include as part of your answer. You cannot just put yes or no. And it's not asking you if they're linear or nonlinear. Okay, so when you see the word proportional, you've got to do things a little bit different and you've got to see if it passes this test. And if you get something like on this one, right, I can do this one up here really quickly. This would be 10 over 2. This would be 14 over 4. This would be 18 over 6. Notice I'm writing the Y over the X. This one will be 22 over 8. Reduce them. That reduces to 5. That reduces to 7 over 2. Do I even have to keep going? Do I need to even do the other 2? Does it matter? Nope. Right away, you can write no. And this work right here is what you circle. All of that as part of your answer. Okay? Sound good? All right. Go ahead. If you're done with it, go ahead and pass in 8-4 and 8-5. If you're not done with it, keep it and finish it to get full credit. Okay? I do want you to get some 3-ring binder notebook paper out, and we're going to start on 8-7, but I don't want you to write 8-7 quite yet in your notes. We're going to do a few review notes that are going to kind of add to 8-4 and 8-5. 8-6, it's not labeled as 8-6, but that's what your Khan Academy was learning how to use that slope formula. Coordinate. Yeah, what did I put? Oh, yes, that's what I meant. He was still marked temporary virtual in the grade book. Oh, well, he's here. Yeah, that's been a fight already, but okay. Yep. About 10 times in my class and about 4 or 5 times already in the hallway, I've said, put your mask up. So, yep. Okay. 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 Well, if I see him with it down, I'll keep sending him to you. Okay. Well, that he needs to know that if he keeps it down under his nose, he's got to go home then. All right. Thanks. Bye. Okay. Yes. I moved them over there to kind of keep everybody away from me earlier in the week, which turned out to be a really good call. All right, so you already have notes from 8.4 and 8.5, okay? And then 8.6, you have notes on, but they're your Khan Academy notes because that's what 8.6 was. So the first little part of this is going to be some review. This 8.6 notes is going to be some review. And then I'm going to have you add a couple of things to your 8.6 notes or your Khan Academy notes, and you don't have to label it. It's fine if it goes under your Khan Academy. And then we're going to move on to 8.7 today. All right. And I don't know how far we'll get into 8.7. I didn't get all the way done with it. So homework was kind of limited, and I think that's just fine. So, all right. So this is a review, 8.6. If you already have this formula down in your notes, you do not have to write it down again. Okay. But this right here is what I'm concerned with you having. Slope equals x or y2 minus y1 over x2 minus x1. Okay, that is the formula to find slope when you're given 2 points like our jump start. And this part right here is just what it means. It's rise over run. It's the change in y's over the change in x's. But the actual formula that will help us like for our jump start is what I need you to really make sure you get down. Okay. And if you think about what change in y means, it's how does your y go, you know, like what's the change from one point to another? And the way you find the difference between one point to another is always subtraction. So it makes sense that subtraction would be change. All right, and this is just an example, and you do not have to put this in your notes, okay? But we're just going to talk about it really quickly. This is a change in y over change in x, and it gives us the points, and it also gives us a graph. So when it gives you a graph, which change in y is right here, this is your up and down, right? Your rise over your change in x, which is your run. Well, if we count our rise, it's 1, 2, 3, 4. So it's plus 4 is our rise. And then if we count our run, it's 1, 2, 3, 4, 5, 6. So it's a plus 6. So if we do it just by counting rise over run, we get 4 over 6, which reduces to 2 over 3. Everybody good with that? That's doing it by counting your rise over your run. If we do it mathematically using this right here, we're going to label, right? We'll call this x1, y1, and we'll call this one up here x2, y2. So using our formula, we would have 3 minus a minus 1, which goes plus. And then for our x's, right? Our x's, we would have 4 minus a minus 2 or plus 2. 3 plus 4 or 3 plus 1 is 4. 4 plus 2 is 6. And again, it reduces to 2/3. Notice we get the same answer, whether or not we count it by doing rise over run, or we plug it into the formula and we find it by computing the mathematics part of it. Okay, good there? All right, you don't have to write any of this down. This is just a little bit of a reminder. Okay, when you're given a graph, count it. Okay, there's 2 ways to do it. You can either count it or you can compute it. If you're given a graph that's marked really nicely, count it. Okay, do your rise over your run. And then your slope is just, that's the easiest way to find slope if you're given a graph. Okay, if you're not given a graph, then you've got your x1, y1 and your x2, y2, and you have to plug it into your formula and compute it. Okay, 2 ways to find slope. All right, this is just practice. I think I'm going to skip this. I don't want to belabor this anymore. You've got your, now here it's not rise. It even says rise, and that's fine. But notice it's a negative. It's a fall. So you fall 1, 2, 3. So it would be a -3. So you just have to watch when you fall. You've got to make sure you don't forget that negative. Okay. And then, of course, when you run 1, 2, 3, 4. And so your slope here would be -3 over 4. And remember what I said in the video, if your line is going downhill, you should have a negative slope. If your slope is running uphill and you get something like -2 over 5, that should be a big red flag. Can't have a negative slope with a positive running uphill line. Same way with your downhill line. You can't get if you forget and you just put 3/4, okay, which is pretty common. If you just put 3/4 as your slope, Damien, Stand up. It's okay. Just stand up and shake it out a little bit. If you have a slope running or a line running downhill and then you get 3/4 as your slope, that should be a big red flag that there's something wrong because you have a negative slope and a positive line or vice versa. Okay. So just use that as kind of a last minute check just to kind of help check that you have it right. Okay. All right. I want to talk about special cases and I do want you to add this part to your notes. Okay. Here's what I don't want you to put in your notes. Don't put all of this. And I'll tell you why here in just a second. Okay. That's a lot of math behind why this works, but I'm going to show you a very nice and easy shortcut. Autumn, do you need to move up? Go ahead. You're more than welcome to move up wherever it makes it easiest to see. I can see you squinting. All right. The part I put a box around is a whole lot of math for how you get your slope for special case lines. Special cases are your vertical and horizontal, and we've dealt with those before as far as what the lines look like. Here's the quick thing I want to show you, okay? A horizontal line, whoops, get my highlighter. A horizontal line makes a Z, and the slope is 0. It's a very quick memory trick that you do not have to do any of the math in there. If you're shown a horizontal line and you're asked what the slope is, you can just write 0 if you remember the Z trick. Okay, make sure you put this in your notes. If you have a vertical line makes an N, and N stands for undefined. So those are your two slopes for your special case lines. Now the math behind it is because if you pick 2 points from a horizontal line, you end up getting a fraction with a 0 on top, and anything with a 0 on top reduces to 0, right? And in the undefined example or the vertical line, when you plug in any 2 lines on a vertical line, it doesn't matter what 2 lines you pick, you're always going to get a 0 in the bottom. Well, what's the math rule about a 0 in the bottom of a fraction? Yeah, not a math thing. That's a big math foul, right? You cannot have a 0 in the bottom of a fraction. It does not reduce to any number whatsoever. It's just simply undefined. So if you're given a worksheet and you're asked to find the slope, any catty corner line, whether it's a real steep one or a real shallow one, any catty corner line is always going to have a slope, rise over run. Any horizontal line is always going to be 0. And every vertical line is always going to be undefined. If you can remember the little memory trick, you save yourself doing the math of it all. Okay? All right. Now we get into 8-7, which is our new stuff. So go ahead in your notes and put chapter 8-7 so that I can see in your notes that there's a definite part in. So when I do a note check, and write this equation and what everything equals or what everything stands for. All right, we're familiar with the slope-intercept form, y equals mx plus b. Okay, it's a linear equation. When you graph it, it graphs a straight line. And in it, you have the m, which is the slope. We've already talked about m stands for slope. And the b is the y-intercept. And that means where your line crosses the y-axis on the graph. Okay, that's what the y-intercept is. It can be positive or negative. So if this is y equals mx minus b, it just means that you have a negative y-intercept, and that's okay too. All right. So if you go ahead and write this example, this y equals negative 2/3 x plus 3, write that example down in your notes. Y equals negative 2/3 x plus 3. If you are asked to identify the slope and the intercept, these are super, super simple. Okay, so I've kind of broke it down over here. I've just rewritten y equals mx plus b. You don't have to do that. And then I wrote the equation right under it, and I kind of color coded everything. If you're asked to find the slope of y equals negative 2/3 x plus 3, you just simply look for the number that's in the m spot, and that is your slope. So if you're asked to identify the m, you just find the m in y equals mx plus b and write it -2/3, okay? Same thing with the b. If you're asked to find the b or the y-intercept, you just find the number that's in that spot, and that is your answer for b. And if it were to say mx -3, it would be, your b would be -3, but in this case, it's positive. So finding your m and your b is super, super easy. Finding your slope and your intercept is really easy when your equation is in y equals mx plus b, all right? But I want to give you an example when it's not in y equals mx plus b. So I want you to write down this example, this 4x minus y equals 6. And in the instructions, we are asked to state the slope and the y-intercept, which means in our answer, we need to have an m equals and we need to have a b equals, right? But in order to know what m and b are, we have to get this in y equals mx plus b. Because right now, everything's jumbled. It's in the wrong spot. But you guys, this is the reason why we kind of map out pre-algebra builds on itself. We know how to move things around, right? We know how to rearrange equations to get y by itself or to solve for y. So I'm going to minus 4x and minus 4x. And that's going to leave me -y equals. Now I'm going to write -4x plus 6 because I want this to be an mx plus b. So I need my x to be first in line on the right. Does that make sense? On the right, I have a +6 and a -4x. I need to write the -4x first. Then I need that negative off the y. So I divide by a 1, but whatever I do to 1, I have to do to all. And I get y equals -4 divided by -1 goes positive. +6 divided by -1 is negative. Now, can I very easily identify my m and my b? My m is whatever number is in front of the x. So my m is 4. My b is whatever number is at the end, and that's -6. Because I rearranged it and put it in the proper order, now I can very quickly pull my m and my b out. Okay. And I want to do one more example. We're going to do number 2, and then I'm going to give you your homework. And I'm going to pass out your homework while you're writing number 2 down. Ah, shoot. Yeah, I can do it real quick. I'll pass these out in just 1 sec. Yeah. So just really fast. I'm going to subtract 3x because I want the x over on the right. That's going to give me 2y equals -3x plus 8. Then I'm going to divide by 2 all the way across the board. And I get y equals -3/2 x plus 4. And then identifying my m and my b now is easy. Whoops. Here's my m. And here's my b.
When you write your slope, you might always put your negative on top too. Sometimes they get lost if you put them on the bottom.
Okay. When I pass this out, I want to make sure everybody knows what you're supposed to do. Okay. 8-6 is a review. It's odds only. Okay. 8-6 is a review. Odds only. 8-7, you only have 3 problems to do. Just the 3 across the top. 1, 2, and 3. I'll say that again once everybody has their paper. I apologize for running over, guys. I know it was a lot today. I get you in the. Okay, once everybody has their paper, on the side 8-6, it is odds only. This is review. On 8-7, just for tomorrow, you'll eventually do more, but just for tomorrow, do problems 1, 2, and 3. That's it. All right? Thank you, guys. I appreciate your patience. I'll see you tomorrow. Holler at me if you have any questions.